Hey everybody, welcome to the official start of Module 2. Module 2 is linear and exponential functions. We're going to kind of study the linears first, then we'll break into exponentials in the second half of the unit. And I thought to begin with, it would be smart for us to study one of the key components of a linear function, which is a rate. So we're going to look at rates of change and various ways they come at us, because in these application problems we're going to look at, sometimes they give us rates that aren't quite clear, and there's other ways of there's multiple ways of looking at rates and finding out what exactly they mean. And the very first one we're going to begin with here in 2.1 is something called a unit rate. All right, so just to make sure we all understand, a rate is a quantity measured and compared to another quantity. For example, miles per hour. When you see a speed limit sign, that is a rate. You're allowed to go 55 miles every hour. Or a cost. If you look in the grocery store and steaks are, I don't know, $8 per pound. Well, that means you pay $8 for every 1 pound of steak. All right, now, there's a special rate that comes along called the unit rate. For example, take a look at this little example I put down here. What if you had a speed limit sign? Imagine this. This is a rate. Imagine a sign saying the speed limit is 20 miles per 2 hours, or every 2 hours. It can be written as 20 over 2. Now this is a rate because it's comparing one thing to another. It's comparing a distance and a time, right? And so we do have a rate here, a change in distance over a change in time. But it would be much better to look at it as a unit rate, because a unit rate has a denominator of 1. So when you're comparing something, it's per 1 unit in the denominator. If you have a rate such as a price per some number of items and the quantity in the denominator is 1, you can calculate a unit rate simply, and I'll say it simply, by dividing the denominator into the numerator. That's how you create a unit rate. That is something that's confusing. Consider this, if we look at the same rate. We would convert it by simply dividing the denominator into the numerator, and you would get 10 miles per 1 hour, which is 10 miles per hour. And notice, as we look through this text, we're going to find that we're looking at the word per oftentimes to tell us, will indicate a unit rate, like 55 miles per hour. And this is a really easy thing to work with, guys. So this delta mass should be simple. I'm just covering this because I know we're going to need it eventually. And I wanted to do a couple of problems working this out. So here's some examples. Here's one. A skydiver falls 144 feet in 3 seconds. How far does the skydiver fall per second? So this is us creating a unit rate. If we want to know the rate at which this skydiver is falling, it would be easier to view it as a unit rate. So you would set it up like this. And it is this simple to do. So we're going to say 144. And we'll use FT for feet for every 3 seconds. We'll call it S. When you divide 3 into 144, you get 48 feet. And we'll go per second. So that's called a unit rate. Much easier to work with, right? Because the question could come after this. It could have a follow-up and say, how many feet will the skydiver fall in 7.5 seconds? Well, that's really hard to answer with this rate. But with a unit rate, that's pretty easy, right? It'd be pretty easy. We'd multiply this by 7.5, right? Okay, let's get to the next one here. Oh, it says a pump moves 42 gallons in 7 minutes. Find the unit rate. I think you guys get the picture here. We're going to set it up the same way, and we're going to use some abbreviations. Gallons we'll call GAL. And it says per what, 7 minutes? Yeah, 7 minutes. And again, divide the 7 into the 42. We know that it goes 6 times. So 6 gallons per minute. Much easier to work with. And finally, our last one down here. And I'm telling you, when we get some of these word problems, the reason we're doing this is they'll give us rates that aren't unit rates, and it makes them a little harder to work with. And if you create a unit rate out of it, you got it made. You score 84 points in 6 games. How many points per game? Again, same tricks, just divide. So we have 84 points per, or every 6 games. And that goes into 86 goes into 84 14 times. 14 points per game. And that's how you create unit rates. Unit rates usually have this little slash and then the other unit right here, which means per 1 game, right? Because that's still 14 over 1. Anyway, the delta math should be pretty easy. Let me know if it's not. This video hopefully was helpful for you, and I will see you when we start talking about average rates of change in the next one.